Hello to the respected Professor Dr. Sampok and all guys who watching this video. Today I am going to presenting you a case study on jamming keeper. Before I am going to show what is this jamming keeper is, what is this study is, let me introduce myself. My name is Rishikesh Arim and I am a fourth year student of Kasetsart University Sriracha campus. I am studying mechanical and manufacturing engineering. The motivation to choose this study is because I am doing a project on this jamming keeper also. So let's see what this study is. Jamming keeper: input, output, grip and toss. Guys, I know the most of you is thinking what is jamming keeper. This is jamming keeper. You can see the photo on your screen. This is phototypes of jamming keeper. Jamming keeper use a soft rubber bag filled with the Garula materials that can expand and contact based on a pressure. The Garula material is able to surround an object when pressed into it. When the air is removed, the materials solidified around the object, locking the project to the gripper. If you are interested in learning more about jamming keepers, view the Universal Lobetic gripper based on the jamming of Garula materials that describe the concept in much more details. The case study on jamming keeper: input, output, grip and toss. It is the study of how problems have been solved by the natural and the development of technology device from biomimicry. In the laboratory of the Chicago University and Cornell University, engineers are experimenting with a technology to picking up and moving objects that seeming has no antecedent at all. There are no fingers, or claws, or magnet, or suction tube acting on balls, or eggs being grabbed. A surgery balloon locked on top of the project, throw it in, and then left it up. Even more surprising, the balloon can also spread out the object with enough accuracy that a robotic arm equipped with such a gripping can repeatedly sink shot through a miniature basket hook. They call this device the universal gripping, and they are also working on using Garula materials to help pick the combined robot together. The ground coffee is loose and flowing within the balloon under normal pressure, but when the air is checked out, the ground picked together and from a solid check that hold its shape even when pressure with a great ideal of force. You can call this behavior jamming. Any Garula materials will exhibit jamming transition. Think like sand, salt, flour, or even in this case ground coffee. When they are loosely combined, they can flow, but when they are picked together, the behavior of total group is much more like solid. The jammed parties push against top of the side of the object to be lifted, and the rubber of the balloon provide enough frictions to create a grip. The grip of the gripper is surprisingly firm. A simple balloon and ground coffee keeper was able to put up and moving an object weighing 650 grams. But the researchers wasn't looking at the ability of gripping, but they are looking at the ability of throw. In order to keeping grain of ground coffee from closing the section line, and engineers would periodically blow air through the tubes. The main of the searching of the study is to how shooting the things from the gripper out of the way. They found that they didn't just eject objects from the grip faster, but also send them into different distance, working with balls and another small objects, the gripper would pick each up, maneuver into position, and then receive a tenth of a second burst of air. The researchers believe that as the balloon blows out, it isn't impressing force to the ball but imparting the velocity to expanding membrane to object in its grip. The universal jamming keeper has some definite advantage over another sport of robotic hand. It doesn't require special programming or orientation to pick up irregularly shaped objects, and because it doesn't have any joint or fingers, it would prove to be more robust in current environment. So this is all about from me. I hope you all will get some useful information from my presentation. And before I leave, I want to tell you that I have a full text of this study in my description box. You will get and read from there. And before I'm going to stop that, I will tell you that be helpful and be handy. Thank you.